Hi friends, welcome to my channel Cloud TV. In this channel, I create videos on different technologies like big data, machine learning, and programming languages like Python and Scala. Please subscribe to my channel if you are not subscribed earlier. Thank you for people who are supporting my channel. I really appreciate it. Please share your feedbacks and clarification and queries on each of the videos comment section. Okay, click on this bell button to get notified whenever I add new videos. Okay, let's jump on to the today's topic. Today I'm going to discuss about so we were last few of the videos we were discussing about RDD transformations and RDD actions. Okay, so we want to see the next level of high level API. So RDD we call it as low level API in Spark. So high level API like DataFrame, dataset, and Spark SQL. There are a lot of high level API available. So we'll see what is the use of those high level APIs, and then what is the issue with the current low level API RDD. Okay, then we'll move on to the example of creating high level API using DataFrame. Okay, so I just want to discuss few point about issue with the RDD. Okay, so RDD transfer. So RDD is a resilient distributed data set, right? It's a distributed collection. Okay, and it gives you fault tolerant. Okay. So RDD has two type of operations. One is transformation and action. Okay, so what is the problem with RDD? Why do we need the high level API like DataFrame and dataset? Okay, so basically RDD transformation will not have any idea. Okay, any idea about the logic of the function which you pass to the transformation. Okay, so basically it will just take the function whatever passed to the RDD transformation, it will apply on the RDD. Okay, it RDD cannot do any optimization. Okay, because it doesn't know the logic inside the function you pass. Okay, whatever the logic you pass, it just go and execute on the Spark cluster. Okay, so when you work on the structured data, okay, when you work on the structured data, so it is better to look for high level API like DataFrame. Okay, because it will give you more optimization out of box. Okay, so I will show you before I discuss about DataFrame. Let me show you the example of what is the problem we have with RDD. Okay, so let us jump into the code. Okay, so this is the simple Scala code I written. Okay, so in this what we are doing is apart from creating a Spark session, okay, I create a simple RDD. Okay, which has a collection of department and the people, the total salary each department has. Okay, so it's a department wise salary. Okay, so we have a department like admin and HR. There are three records in this three element tuple in the list. Okay, so when you do a parallelize of your Scala list, it will become a RDD of key value pair, because we are passing a tuple, right? So it will have a key value pair key value pair RDD. Okay, so then what I am doing is I just want to find out average of each department, the average salary people getting in the department. Okay, you just find out the average salary. So how do you find out? So you take the key value pair RDD. Okay, apply map transformation. Okay, so what is the function you pass? You just take the key and the value you want, actually the value you want to create one more tuple saying value comma like 2000 comma counter 1. Okay, you are sending the counter for each salary, department salary. Okay, then you apply the reduce by key. Okay, based on the department you apply a reduce by key. So here there is a one anonymous function we are passing. uh, okay, here also they are passing one more anonymous function, that so you group or reduce by key does it groups by key, and each value will be uh, each value will be aggregated based on the function you pass. What your function you are passing is basically I am just summing up uh, all the values in the this key value pair. Okay, value of key value pair, which is the value of 2000 comma the counter 1. So it becomes for this it will be a 2000 comma 1, and the result of this reduced by key. For this you will get 6000 comma 2, because there is a 2 entry. Okay, so it will become, so that's what we are doing. So first element um, a plus uh, uh, a plus first element and b plus first element comma a plus second element comma plus a plus b plus second element. Okay, so it gives you like uh, for first for this it will give 2000 comma 1, and then there is one more entry. For this you get 4000 plus 2000 will be added. Okay, here, and the counter will be added in the second the value, the key value pair. So it will be a key value pair of 6000 comma 2. Okay, then what we are doing is again the result of your reduce by key operation will gives the RDD of key value, right? So key will be your department. Okay, so what we are doing is value will be a key value pair of this one, right? So we are just this key by value, it will give the average for that department. Okay, so 2 by 1 become, sorry, 2000 by 1 is 20,000 2000, this department average salary, and for this department average salary 6000 divided by 2 will give about 3000. Okay, so what we are trying to say this, the RDD cannot apply any optimization on this the logic which we passed as a function passed to this transformation, because okay, whatever function it is passed, that will be executed on this RDD. That's it. It will give you the new RDD whenever this transformation applied. Okay, then we print this. Okay, say example you want to apply a filter, okay, on this calculation. Okay, basically I add a filter here. Okay, saying that I want to find out only the department which has records like records which has the department of HR. Okay, so I apply this filter after reduce by key. Okay, so what this RDD will do, again it will simply go and do the aggregation, and then it will try to filter the department HR, which is not a effective execution, right? Because it is better to filter before doing the aggregation. Okay, so so like the programmer has to know the way we need to write a programmer. Okay, write a program in efficient way, but sometimes we also fail to write an efficient program, right? So that's the reason we need some optimizer within the Spark framework, so that we are actually focused only on the calculation, not on the optimization. Okay, so that's the reason they introduced a module called Spark SQL. Okay, so so if you compare with the RDBMS, typical RDBMS, so this will be a typical SQL query you can run for the above calculation. You just say select department comma average of salary from employee, where department equal to HR. Okay, HR and group by department. So the SQL execution engine knows the schema of employee, okay, and it actually parses your query, and it know how to optimize, like it knows we need to apply a filter before doing the group by operation, okay. So that is the that is the out of box feature in the RDBMS databases. So similar way, okay, they introduced the Spark SQL in Spark execution framework, okay. What it which introduces a structure to the data, okay. It will give you a stick table like view for your structure to the your data set, so that you can apply the SQL operation or the data frame operations on the structured data, okay. So so that's how they started building a Spark SQL, and inside Spark SQL they built a data frame and a data set, okay. Now let's get the few insight about data frame, okay. So what is the need of database? So it gives a table like view, because of that it's user friendly and easy to use, and also it's efficient, okay. The importance of your important use of data frame is the performance. It improves the performance. How it improve the performance is, so it out of box, okay. There is a optimizer called catalyst optimizer, okay, sorry, catalyst optimizer. So your data frame operation goes through catalyst optimizer. So all the optimization takes place in the catalyst optimizer before sending for execution as a RDD, okay. So using this way we can actually optimize the computation better way, instead of using the RDD, okay, which does whatever you do, whatever computation you pass, it will just go and execute. It will not do any optimization, okay. That's a need of data frame and a data set. Data set is the typed you can say typed abstraction, or typed high level API in the Spark environment, okay. So data frame is actually the type of row, but data set will have the based on the custom or user defined type, okay, in the data set, okay. So again we'll go back to the program, okay. So we'll see how to create this excuse me, we'll see how to create the data frame in the Spark, okay. So in this example, what I'm going to do is I'm going to use the existing RDD excuse me, existing RDD which has data for department and salary, okay. From that I'm going to build a data frame. So you just say data frame dot the RDD which the department RDD, okay, dot to df, okay. You pass the column, because in the data frame you have values like this, okay. So you have a department comma salary, department comma salaries, like this. You have a key value, right? Key value list of key value pairs, okay. So with that you are going to create a data frame. So you just pass the column names for your data frame, because data frame is a column and row structure, okay. It's a table like structure, right? It needs to know the column name, okay. So you pass the column name department comma salary, okay, which gives a data frame. From the data frame you just apply the group by operation and do the aggregate average, okay. So you do the aggregate function as average, and also we are applying filter, okay. So if we are doing this one, so catalyst optimizer will take care of doing the optimization, okay. So it will apply the filter before doing the group by operation, okay. So and also it is easy to express, and new programmer, if somebody comes for somebody comes to your team and look for the code, it is very easy to understand. So if you look at this same operation which we do on RDD, it is little complex to understand in the first time. Okay, so you need to dig into the code and understand that. But when you use Spark SQL and data frame operation, it is easy to understand. So let me execute this program and show you. Okay, so next session, I may take different different data frame operation. We can like what are the different operations and functions available in the data frame in the next session. But I request you to go through I prepared one more video exploring data frame using PySpark API. So it is almost similar, you just syntax differs, but the functions are whatever there in the PySpark is same with the Scala API also. I request you to go through that. So if you we can look at here. Okay, so it says so in the first so here. Okay, so okay, sorry. So here you just see this it returns here in the data frame. Okay, okay, I'm sorry. So in the final data frame operation, so it does the aggregate on the data set. Okay, so it gives you the result which we were expecting. Okay, so which is it does the aggregation for all the department for the department HR. So it returns HR as a department, and the average salary is 3,000, which we calculated. Here it is displaying all the okay, so yeah, it is actually output of two different results set. Okay, I just got confused. Okay, so here in the first operation, it gives you the both department, right? Admin and HR department average salaries displayed here, and followed by this result, which is where we do the filter operation for HR department. So it was just combined. Both are mixed here, so it was okay. Let me introduce separation here. So let me see. Printing data frame result, data frame operation result. Result here. Okay, just to enter here, I will copy paste this text. I'll say setting RDD operation result -1. I'll say here, and the same thing. And just say result, only result. Just let me run this again, just to get differentiate. The result output is correct, just to make sure you understand this point. share. Okay, so this is the result of first RDD result we made, and this is for after applying the filter for HR department. This is similarly for after applying the HR filter for HR department, but using the data frame operation. So we this is how the usage of data frame or a data set and Spark SQL comes, okay, over the RDD operations. Okay, so whenever you want to write a efficient computation logic for your data processing, you better to use Spark SQL or data frame or data set, okay, rather than RDD. Okay, thank you so much, friend. That's what I want to discuss in this session. Okay, please subscribe to my channel to get more technology videos. Okay, so I will see you in the next video. Okay, thank you so much, friends.